everyone, and welcome to the April edition of the WinUI Community Call. I'm your host, Gabby, and I'll be hosting today. About the Community Call. So the WinUI Call takes place on the third Wednesday of every month at 1600 UTC, which is 9 a.m. Pacific time. Our next call is going to be May 18th, and we'll have some extra special surprises. You can reach out to us on GitHub at Microsoft UI XAML or Windows UI on Twitter. Here's a slide for those of new to the WinUI Community Call, doing a bit of an outline about WinUI 2, 3, and Windows App SDK. Please feel free to come back to the recording to take a look at this. All right, so today we have a pretty packed agenda. We're joined by Johan from the PhoneLink team to give us an app spotlight for how they migrated from UWP and to WinUI. I'll also be sharing a bit of info about our road to Windows App SDK 1.1 and what's remaining. I'll also give a brief update around how we're engaging on GitHub. And then we'll also be joined by Scott, who will be talking about hybrid CRT and giving us the latest updates. And then, as always, we will close with Q&A that's provided by GitHub and then live in chat. So feel free to leave your questions and comments, and we'll be sure to pick those up at the end. Awesome. So then I will hand it off to Johan. Hi, Johan.
Having me on the call today. I am an engineer on the PhoneLink team. You can find me on Twitter at jplanza and on GitHub. And today I will talk about how we as a PhoneLink team did the migration from UWP to Windows App SDK. So let me start with just a quick introduction on what is PhoneLink. PhoneLink is the new name for an inbox app in Windows called Your Phone that brings your Android phone capabilities and content to your Windows PC. And so you can read and reply to text messages, view photos from your Android device, use your favorite mobile apps on some Samsung and Honor devices, make and receive calls, and also manage your device's notifications right on your PC. PhoneLink in its current state is a mix of a UWP app with a desktop bridge component that we use for connection management and some other things. The desktop bridge maintains the connection, allows communication between the devices, and because it's not constrained to the UWP app lifecycle limitations, it is a desktop bridge component. Because of historical reasons, both components use a mix of C++ and C# code on .NET Core for UWP, .NET Framework, and we even have some things that run on .NET Core 3. Not the greatest combination of technologies mixed up. The Windows App SDK allows us to simplify this, removing the limitations that we get from the UWP app lifecycle, removing the need for a separate desktop bridge component, enabling all our .NET code to run on .NET 6, and to also reuse our existing XAML UI. So we started this migration a few months ago, and because we need to continue to ship our current UWP based app, we went with a solution that gives us the ability to ship both our Universal Windows Platform app and our Windows App SDK based app simultaneously. And so we have two VS solutions that are sharing the same projects, and we use conditional compilation and some other techniques to share 95% of the code between both apps, which works for both C#, C++, and IDL, and allows engineers on our team to continue to build new features in the normal way that they do this, and they will both automatically be added to the UWP and the WinApp SDK app. And so we have two build definitions that build those two solutions for every pull request, as well as every merge, every continuous integration. Some of the challenges that we ran into when we were migrating PhoneLink from the UWP to the WinApp SDK app is that while we have if-defs for C# and C++ code, we don't have if-defs for XAML code. And so, because there's no if-def for XAML. And so in those rare cases where we actually need to specialize XAML because of controls that exist in one place but not in the other, we simply created 2 XAML files temporarily and conditionally included those files in the relevant projects. The other thing that we had to solve is, of course, Windows App SDK apps are multi-instance by default, while UWP apps are single instance by default. One of the components in the Windows App SDK, the app lifecycle component, allows you to easily make this work and make your app to be single instance. Other challenges are with the use of APIs that call get for current view. As some of you might be familiar, there is no get for current view API in Windows App SDK. And so in every place where we call a get for current view variation of some API, we had to find a replacement Win32 equivalent. The other thing that's interesting is that background tasks, which were traditionally a UWP only concept, were later enabled to support Win32. There is a concept called a WinMain or Win32 background task, in which case only some of the triggers that the UWP platform supports are supported for those Win32 background tasks. And so since we used quite a few of the triggers that are not in this supported list, we had to come up with a solution for this. Then we have some current limitations still in the tooling. For example, a runtime component, self-contained, is not entirely working with the tooling as it is today. And we ran into some issues with where the parallel patterns library and when you set desktop compatible to true causes some threading issues, which applies to C++ only code. I made a sample on GitHub, which contains our solutions that we have in the phone link app today that show how to solve each of these items listed in the slides. And the sample is on GitHub under my GitHub account, github.com/jlancer/WinAppSDK-samples. And in this sample, you can see how to make a WinAppSDK to be single instance, conditionally replace get for current view APIs, make background tasks work with a CS WinRT runtime component instead of using WinMain background tasks. That is, of course, fully optional. You can use WinMain background tasks if the triggers that you need are supported. How to make a self-contained runtime component, as well as how to work around the current issue with the PPL and desktop compatible is true. That issue is being worked on by the WinAppSDK/C++ team, so that would eventually go away and the workaround would not be longer be necessary. And then what you end up with is, if you clone this, you end up with 2 solutions. One is the WinAppSDK app solution that is in the GitHub repo that essentially shows an app with a package project, then a shared C# project and a shared native project, and then shows how to do background tasks outside the main app that then will activate the background task inside the sample app. And so you can trigger that in Visual Studio using the debug location toolbar once you run the sample. The other app that is in there is a UWP app, also with a package, also and sharing the shared and shared native projects. There's no background tasks project here because background tasks within the main app are supported by default in a UWP app. And then let's go back to the slides. So what's coming next for PhoneLink? So the goal is to ship sometime in the second quarter of 2022 on Windows App SDK 1.1. We are super anxious to add Mica later once that is supported, and to build further on top of the improved multi-window support that Windows App SDK gives us. You can try PhoneLink today. Go to aka.ms/PhoneLink to get the app, set it up, and then once we are ready to roll out the Windows App SDK based app to a larger audience, you will automatically get the update. Back to Gabby.
Awesome. Thanks, Johan. It's great to hear what's coming next with PhoneLink, bringing to WinUI 3. Folks here listening on the call, sorry for some of our link mix-up at the very beginning. We're moving to it. As you may have seen, the call looks a little bit different this time, and so we're moving to a little bit of a different process, and there's a bump in the road. But to look back at Johan's info at the very beginning of the call, you can definitely check out the recording. Otherwise, I was just letting you all know what the call will be about, so now it'll be a little bit more of a surprise. So thanks, Johan. It was great to hear more about PhoneLink, and if you have any questions for him, please feel free to ask them in the chat. So now I'm going to give some info about Windows App SDK 1.1. So here on this screen is a few of our releases that we've previously done. So it started off with Windows App SDK 1.0, and then we've done a couple of servicing and a couple of previews until then. As part of these servicing and preview releases, we've been able to fix or create features that you, our community, has brought up to us. So thank you for bringing that feedback to us, filing those bugs. Some of those are pretty severe, and so it was great that we were able to address them and you were able to bring those to our attention. Let me see. Awesome. So what's coming up next before we release Windows App SDK 1.1 stable? So we're expecting to have another preview release, Preview 3, which will have additional stabilization across Windows App SDK. And this release should include Mica and background acrylic. We're also expecting one more 1.0 servicing release. And then in Windows App SDK 1.1, here's a list of the features. This is from our Windows App SDK roadmap, which you can see at aka.ms/WinAppSDK roadmap. But it's also what we presented at our last call. So this includes apps being able to create multiple windows, mic and background acrylic, improved default and custom title bar. Apps are able to run with elevated permissions, self-contained deployment, push notifications, more environment variables, and more restart APIs. So we're really excited to share that with you all and continue to keep the feedback coming about our preview releases. We are planning on addressing those in the next preview, and we'll let you know about that status on GitHub. So speaking of GitHub, I wanted to share the latest info on how we're engaging on GitHub. So as of right now, we are routing issues daily by tagging with product area and team. We're adding new labels to better route and triage issues. So routing is, the initial intake of an issue, and then the triage to eventually accept or reject a bug or an issue. So we're establishing a predictable rhythm of triaging and defining our triage expectations. We're trying to be a lot more clear about what will happen with an issue after it's filed. So we see some outcomes like an issue is assigned to a milestone and we're expecting to fix it if it's a bug, or we will say, sorry, this is out of scope at this time, and we'll close the issue. So we're evaluating these issues based on how they align to our focus areas. So you can take a look at our roadmap for more on that. But we'll be continuing this process. And of course, as always, feel free to give us feedback on how this is going as we continue. But soon, and it's on my to-do list, is to clean up our huge backlog of issues by ensuring each issue has an accurate product area and team label. So that means each issue is routed. So then we can figure out what we should do with each of those issues. I'll also create and manage a discussion section for answering questions and hosting discussions in general. I know a few of you asked about this in our last call. So we're just trying to get that set up and make sure that we're giving it the right attention that it needs. Awesome. So a bit about 1.1. We're introducing hybrid CRT. So as part of that, to give us a little bit more information, we're going to bring on Scott Jones. Awesome. Hi, Scott.
Hello, Gabby. Hello, everyone. Yes, I wanted to share a bit of some of the behind the scenes work that we just did to improve robustness and simplify deployment. The problem that we ran into, which Gabby just alluded to on one of her slides, issue 2117, I think it was, but it's been opened several times on the GitHub issues tab, is that some of our Windows App SDK binaries, most of them, in fact, were dynamically linking to the C runtime. And the result of that was that was a responsibility that fell to the app developer to ensure that the C runtime redistributable was deployed to a target device. Otherwise, one or more of these Windows App SDK binaries would not load. And so if you were an enterprising developer and could track all this down, you would discover this linkage of our binaries to VC Runtime 140 and other DLLs. And so the solution that we came up with was what we call hybrid CRT, which as of yesterday is now available in Windows App SDK releases 1.03 and 1.1 Preview 2. So I wanted to get in a bit of, into what the technology is, what the technique is, and how you as C++ app developers might make use of it yourself to simplify your own deployment. So historically, there were two linkage options for the C runtime. You had dynamic, which is where you would have runtime imports from VC Runtime 140, DLL, etc. There's about a half a dozen related C runtime DLLs. The majority of the code coming from VC Runtime 140. And there was a redistributable that was required to ensure that these DLLs were placed on the target device, VC Redist, and the architecture. And the result was that you would have smaller binary sizes. That was the pro to this technique. And this was the default, by the way. If you wanted, you could switch over to static linkage, and then you would have no runtime dependencies, no redistributable, but you'd have a larger binary. So those were your trade-offs historically. Moving forward to Windows 10, we did a major refactor of the legacy MSVCRT DLL into two parts that we called stable and unstable. The stable part ended up in the system as a system DLL, UCRT-based DLL, as you see here, over a megabyte. And the so-called unstable parts, which really means the parts that are versioning frequently. It could include bug fixes, but it's really more the startup logic that would wrap your WinMain, DLL main routines, as well as intrinsics, exception support, and so on. Things that you need to have inlined in your binary that you don't want to hop over a DLL import boundary for. Those would end up in VC Runtime 140 if you dynamically linked. If you statically linked, those would end up in your image. So this was the split. And the result was that from Vista forward, 90% or so of the C runtime is already on the system, which opens up some opportunities for us. Furthermore, with Windows 10, we had two different models for CRT linkage and redistribution. We had desktop linkage, which is where you would be importing from DLL, VC Runtime 140 DLL, located in the System32 directory, and the Redist would be taken care of with this executable or a merge module. Or you would have app linkage, or UWP, because you were targeting the Universal Windows Platform, where you would have the same set of DLLs that would be suffixed with APP. Those would be dropped into the VC libs framework package directory, and those would be specified with a package dependency in your Apex manifest for the VC libs. More recently, Visual Studio 2019 introduced a way to support both UWP and desktop linkage by way of a project property, desktop compatible, that you could include in your project and set to true. And then you could include a package dependency to the UWP desktop framework package, which would resolve linkage to the desktop flavor of the C runtime DLLs. You could also use the VC Redist if you liked. So this was a way to converge the names of the import DLLs that the C runtime was producing. So that simplified things in some sense, but ultimately it just created more complexity for developers and users. Okay, so enter the hybrid CRT. So what is it? The hybrid refers to a combination of dynamic and static linking. We're linking dynamically to the UCRT-based DLL by way of API set forwarders. So you won't see linkage directly to UCRT base. You'll see these API set forwarders. And we're linking statically to the remainder of what would have come from VC Runtime 140 DLL, startup code, intrinsics, and so on, as I mentioned. And so now returning to our chart, we have a third row, hybrid, where the runtime dependency is only to UCRT-based DLL, 90% of the C runtime code. So there is no redistributable concern, and you still have a small-ish binary. It's not quite as small as you would have if you linked dynamically, but it's nowhere near as big as it would be if you linked statically. Okay, so let's take a quick look at a demo that is based on a C++ WinRT console app. So this isn't a Windows App SDK project. This is just a very, very simple console app just to demonstrate the trade-offs here. So by default, when we take a look at linkage, we see multi-threaded DLL. So that's the default C++, the C runtime linkage. Let's build, and then we'll take a look at the dependencies. So the dependencies for our generated app include, as you see here, the three of the C runtime redistributable DLLs, as well as the API set forwarders that point to UCRT-based DLL. All right, and then let's take a look at the size of this image. This image is 26K. All right, let's switch now to static linkage. See what that does for us. Build again. And then we'll take a look at our dependencies. No, we didn't build. Let's try this again. I'm sure that's not building. Okay, that's better. So here we now have static linkage, and we see not only no CRT Redist linkage, VC Runtime 140, but we see also no linkage to the UCRT API set forwarders. And the size of the image has gone from 26K to 163K. Again, this is just an artificial example to demonstrate the change. Okay, so we'll leave it on static, but now what we're going to do is we're going to go over to a directory build props that I've created. We're going to import hybrid CRT props. Now, this is a file that we've published on the Windows App SDK repo. Right here is the link to it, but I'll include a shortened link later. And this will give us that combination that I described. So let's do another build. We're now dynamically linking to the UCRT, but statically linking to the remainder. And this time we'll look at the size of the image, and we see now it's 50K. So it's larger than dynamic at 26. It's smaller than static at 163. And also, if we look at the dependencies, we see just the C runtime forwarders to UCRT base. Okay, let's flip back and present that in a little more digestible manner here. So on the left, we've got dynamic linkage at 26K, static in the middle at 163K, hybrid on the right, 50K. And the green API set forwarders are pointing to UCRT base, which is always on the system, down to Vista. And then we see the CRT Redist, which is what we're trying to eliminate. A better example would be the WinUI DLLs that comprise the Windows App SDK. The larger the image, the larger the binary, the better the payoff as we switch from dynamic to hybrid. And in fact, if we look at the Microsoft UI XAML DLL, we actually see a savings in moving to hybrid. So the net in this case of the 4 WinUI DLLs is just 177K increase, or 0.7%, which is very small. It's practically a break even to not have to worry about the redist. A couple of edge cases to go over here. One in particular is the use of UWP libraries, DLLs, in desktop apps. And this would normally carry the responsibility of either a VCLibs UWP desktop package reference for packaged app, or the VC redist for unpackaged. There's 2 ways that we can achieve this. And this would be typically if you've got an existing project and you're in the process of migrating or evolving it over to Windows App SDK, you might have a UWP DLL, a utility DLL, a control DLL, something like that. And it might be using the app flavor of the C runtime, which means it's importing from the _app suffixed DLLs. Well, you can use that DLL in a desktop app if you make use of the VCRT forwarders NuGet package. You might also be using desktop CRT linkage. So you might be targeting UWP in your project, but you may have set the desktop compatible project property to true, which causes desktop CRT linkage. In other words, we're not pulling in imports from DLLs that have the _app suffix. There are 2 ways to deal with, well, I should say that in either one of these cases, if you try to adopt hybrid CRT, you'll end up with a build warning that says that static C runtime is not permitted for universal Windows libraries. And so there are 2 techniques that we can use to resolve that. One is to just switch it over. If you're using this DLL solely in a desktop app, in a Windows App SDK app, then there's no need to target UWP anymore. You can just remove the project properties that specify that. That's probably the simplest way to do it. The second is to suppress that warning that I mentioned. And there's a project property that you can use to do that, which is use UCRT SDK reference static warning, set that to false, and then you'll end up with the same result either way. Another edge case to consider is C++ CX code. I'm not going to get into that a lot, but I'll just say that CX code has deep assumptions about dynamic CRT linkage, and those can be overcome with some overwriting of decorations in yvals.h and a pragma detect mismatch disabling, and then you can use this in your CX code as well, this technique. And that's it. If you have any questions, then feel free to follow up with me or any of the WinUI team and take a look at AKA MS Hybrid CRT, which will point you to a markdown, which will describe all of the techniques that I've just gone over and how you can use them in your own C++ app if you want to simplify deployment. At this point, let me just wrap up, yes, with a summary. So the benefits is that we're eliminating the redistributable responsibility with a modest binary size increase. Applications, we started by doing this internally so that unpackaged and C# apps would benefit, but we found that other folks are finding benefit with this as well, C++ apps. And there's the simplified URL. And with that, I will hand it back over to Gabby for questions and answers. Thank you.
Awesome. Thank you, Scott. That was an awesome overview of hybrid CRT. Folks in the chat, we are joined by Scott, Johan, and the usual suspects from the WinUI team for all of your questions. So definitely please ask us whatever you'd like about WinUI, phone link, and hybrid CRT. So let's see if we can, and then I'll pass it off to Savoy. We can go to a nice, it's great to see everybody like this. Awesome. So Savoy, I will hand it off to you. Start going through questions.
Awesome. Thanks, Gabby. All right, let's dig into a few of these here. Ryan, I'll start with one for you. There's a question here from GitHub where Stefan is asking, when will info badge be available in WinUI 3?
Great question. Info badge. So right now, WinUI 3 has parity with the WinUI 2.6 control set. We will be updating that control set in 1.2, so you can expect that later on this year. It won't be in 1.1, but you won't have to wait too long. It'll still be this year.
Awesome. All right, question for you, Mike. We have Luke Blevins asking, has the OS bug fix for excessive tab view item memory usage shipped yet? If not, is there a timeline for when this will come to Windows or the decoupled UI stack? Or is there a workaround for consumers of tab view until that servicing fix ships?
I think that actually got, there was a hard problem to figure out. That was, a very difficult leak. But I think the fix just got checked in this week, and will be, Gabby mentioned we've got a preview 3 coming up of 1.1, so the fix should be in that preview.
Awesome, thanks, Mike. There's actually a few questions here for you if you're ready for some back-to-back. Ghost1372 is asking, when can we attach UI framework content to an app window? Will this feature be available in 1.1.0?
That's actually what it means to attach to an app window. The app window in WinAppSDK is basically it's a pretty thin wrapper around an HWin. It's WinRT API, but it tries to adhere closely to the HWin and not try and reinvent anything. So basically, connecting WinUI to an app window is like connecting it to an HWin. And so it sounds like what we were talking about is the desktop Windows XAML source API, aka XAML islands. And that's something that we're spent a lot of time working on, but it's not in plan for 1.1.
Maybe I can jump a little here, Mike. So maybe they're asking about that. Today you can't set up the content in an app window. App window is about, there is an HWin, an existing HWin, and you can wrap this existing HWin with all these new property. In the past, we have app window, and app window in system SAML or OS SAML already have a content property. So there, as far as I know, although the teams are right now doing the planning right now for 1.2, but as far as I know, still there is no plan just to have this content property in app window that allows just to put any kind of random UI content. You have to first create a HWin based on WinFront, WPF, Win32, or WinUI, and then create the app window that grab the HWin and grab all this functionality.
Awesome, thanks, Miguel. Another question for you, Mike. Ghost is also asking, when can we use all the multilingual capabilities like changing the language in runtime, just like UWP? Currently, applications must be restarted.
Actually, if you're watching the call, it'd be great if you could stick some more info into the chat on that. Like which multilingual feature you're getting that's automatically refreshing in UWP. I guess there's multiple ways to approach multi-language. There's a feature in XAML markup where you use :UID, and that is done at parse time, so that's not dynamically updated either in UWP or in WinAppSDK, WinUI 3. The resources in WinUI 3 are actually WinAppSDK. The Resource Manager API is different. There's a lot more to the Resource Manager API in Windows than there's in WinAppSDK, and so there's some change notifications on that might be different in your app. But I'm not sure what we were doing in UWP that would be automatically updating like that. So maybe we can stick something into the chat. I can try and follow up.
Awesome, thanks, Mike. A question for you, Gabby. We have Martin Anderson asking, will the new title bar control include extendability, so adding extra buttons with appropriate styles and XAML content?
Yeah, great question to try and understand a bit more info about title bar. So in 1.1, we aren't introducing a new title bar control yet. We're just introducing new APIs, helpful APIs to app window. But a title bar control is something I think we've mentioned in the repo a bit as something that we're considering to try and make customizing a title bar a lot more simple. So there's a lot of things to think about in this area. How can we ensure that interactive content is interactive and the title bar itself is still draggable, and going between interactive content and draggable regions and then back to interactive content. So there's that one aspect of it. And then there's also, how does the title bar integrate with these app-wide controls like navigation view and tab view? So with creating a title bar control, it's okay, is this separate from the app content itself, or is it combined? How will these play nicely together? So me explaining that is kind of a longer version of saying we are still figuring it out. The best way to make all of these scenarios work well in WinUI 3 apps. And as we start to massage that a bit more, we'll post more info on GitHub for feedback. But we're definitely analyzing a lot of different usage scenarios in title bar. So thanks again for the question.
And Gabby, I saw there's a related question from Nirmal asking, when we click on title bar, it opens the context menu with minimize, close, etc. And when we double click it, it invokes default actions, which is close, and it closes the app. Is that something that's coming?
Yeah, so I was actually less familiar with that feature. I'm thinking that was something that's in UWP. So I don't know the status on bringing that to WinUI 3 or Windows App SDK title bars, but feel free to ask that question on GitHub, and then I can add a couple of people who might be able to help answer that for you.
Awesome. All right, a question for Miguel here. Niels is asking, what is the expected timeline for title bar customization APIs? Specifically Windows App SDK app window available on Windows 10, now that it's currently Windows 11 only.
Okay. So first of all, let me clarify something. So the Windows App SDK is a set of different components. Each component have a different things, although we are working all together. Means we are the WinUI 3, there is an app window Win10, there is another thing who takes care of notifications, so all working together. Right now we are in the state of setting all the plan that is going to happen for 1.2. It's right now what is happening. So we are discussing that and trying to create a solid engineering plan. So why I'm telling to you that is because, hey, today we don't know yet all the details that we are going to ship in 1.2 in other things, because right now we are discussing. So, but I can answer the question of the app window for Windows 10. There is some APIs in the app window, not all the APIs, just some of them. All of the APIs related to the title bar that only works in Windows 11. There is a strong feedback from the community that they want to make that happen in Windows 10. The window already have this feedback, and they are right now evaluating whether it's possible just to do this work in 1.2. But right now, we don't know yet.
All right, thanks, Miguel. A question for Mike. There's currently an issue where users are unable to drop an element when drag and drop is enabled. Is there a plan to fix that?
I think this is, I saw this in chat too, and I think I was having a problem getting chat to work. I was looking for a link to a GitHub issue on the exact problem. There's a couple of drag drop problems that I know about right now. There's a problem in the preview where where you can start a drag, but the drop's not working, or it seems like the hit testing is off. If you move over about 200 pixels, then it starts working back where you intended. Anyway, it seems like there's an alignment problem with the pixel coordinate space. That's one issue that we have in the preview for 1.1 that I know about, that we're working on a fix for right now. The other issue I know about is if you're running your application elevated, which is new to 1.1, then drag is just not supported because there's some fundamental design issues that we have to work out. So those are the two issues I know about. It's another one. If somebody can drop a link in the chat to the GitHub issue, I might be able to quickly find more.
Awesome. All right, that came from ArtCat, so I can tag ArtCat as well and see if they can drop an issue for us.
Thank you.
Another question for you, Mike. This one's from Andrew Keep Coding. Love that username. I'd like to know if we can expect a built-in data grid this year or if it might take longer.
I guess built-in might be the key word. There's a data grid in the community toolkit, which has been there for a while, and so that works on WinUI 3. That is C# control. So works great in the C# app. If you're working on a C++ app, either way, built-in is probably not in the roadmap for this year. Unless somebody wants to correct me.
I don't hear anyone taking a chance. So I think we're getting low on live questions here on the call and on GitHub. So Mike, I'll ask you a longer one here, and apologies for the length. I'll also post it in our chat here just so you can see it. We have a question from Harvinder's asking, it seems that many bug fixes from this repo are not making it to WinAppSDK 1.1 preview. Having said that, I really appreciate the team fixing issue number 6076. Could the team share with us about the plan to bring these bug fixes to WinAppSDK? Some examples that come to mind are WinUI 3 desktop still has tab items with shadows. The tab view is still missing the top right border after the last item, and teaching tip fails to open if is open is set to true while it is running the close animation. I think the team has fixed many other issues, and I'd like to understand the timeline to bring these fixes to WinUI desktop, as some are very critical for our project.
All the changes that we're putting into WinUI 2 on the repo are reporting into WinUI 3, WinUI desktop. We don't have a regular schedule for it, not an automated process. There's some manual work involved. So the scheduling on it is somewhat ad hoc. I know we had a problem with, and I think it was a porting problem with the tab view, the corners not showing up correctly to the new style. And I think that fix just went into the preview, and Gabby's nodding her head. Sweet. So that fix just went into the 1.1 preview. So I don't know about any other particular ones, but in general, we're keeping the two in sync, but our schedule is a little bit ad hoc.
Awesome, thanks, Mike. And I'll call out here that we have two guests today. We have Johan here to talk questions about UWP to WinUI 3 migration, and our friend Scott Jones, who presented on CRT earlier. So if any folks on the call have questions for our guests, please feel welcome to post them in chat. Until then, let me take a scroll on what outstanding issues we might still have open, or outstanding questions. Mike, maybe a question for you. Sun Long is asking, will the theme listener API come back? I want to change caption button color when light and dark themes switch.
I'm not sure about the theme listener API. We have theme resource markup extensions in XAML that you can use to reference theme colors and such, and those should be updating automatically. There's a UI settings API, I think it's called, as part of the Windows APIs. I hate to keep posting stuff over the chat, but maybe if there's a specific API you're talking about.
Gotcha. So Long, if you're listening, feel welcome to post that specific API, and maybe we can get you a few more details. I just saw a question from Thomas May pop up here. I know, Thomas, that it hasn't been asked on this call yet already, but Thomas is asking if there's any news or updates on media player element.
Yeah, I can field that one. So
go for it, Ryan.
Yeah, so, and this was asked earlier, but right at the very start of the call, Thomas, so you might not have been in the call or seen it. We get asked this a lot. Media player element is planned for our 1.2 release, which will be later this year, in the fall. So you can expect it to arrive then.
Fantastic. Thanks, Ryan. So as far as I see, that's caught us up on all of the live questions here in chat, as well as all of the questions on GitHub. I do see Cam Gallahan posted a fairly large question on GitHub, but that might be best handled there on the thread. So I think that might be it. Oh
no, I see a few more coming in.
You coming in right at the end here. Yeah, I just saw him too, Gabby. Mustafa's asking, is there any updates on improving the experience for WinUI and VS Code? Is that something anyone can talk to?
Can you say that again, Savoy?
Mustafa's asking if we have any updates on improving the experience for WinUI and VS Code.
Oh.
I can answer that.
Yeah, go ahead, Miguel.
It's tricky, I love it. No, we don't have a plan to make work WinUI 3 in VS Code. However, we are making progress in making work WinUI and the Windows App SDK in the CLI.NET, which is the first step just to make work in the VS Code. So it means that there is no plan, but we are making progress in trying just to be independent of Visual Studio.
And that .NET CLI support is out. That was in, I think, the 102 surfacing release.
In 102, yes, Mike, yes.
All right. Excellent. Well, I did see a question come in for Johan here, where Johan, Kevin is asking whether you're assisting to transition old inbox Win 10 apps to WinUI 3.
So we are one of the first teams in Microsoft to do the transition, and we have various teams reaching out for advice, guidance, support, and so it's all up to those teams to do the transition, of course. But our team is helping out and providing support wherever we can.
I've been one of the teams reaching out to Johan for advice, guidance, and support, actually. Having that experience.
And I help Mike, right? Like, always.
Actually, somebody asked earlier about a data template bug getting fixed, and it said it was fixed this week. Johan ran into it too. I think it's come up a bunch of times before. Internal apps making the switch. Having somebody really close to home doing this work is really helpful for us. Some of the other inbox apps are open source, and so we've been prototyping doing some switching ourselves just to personally learn more from the experiences and get a better feel for what the roadblocks are and the hurdles are for taking an existing app and porting it over to WinAppSDK.
Yeah, and some of the hurdles that I mentioned before on the call, you can see how we solved that in the sample that I put on my GitHub. And if there are specific other migration issues or things that we'll see teams commonly run into, we might update the repo to add the sample for that there as well, or even maybe answer questions in the issue section on the sample to help out for people outside of Microsoft, of course.
Awesome. All right. Well, we have had a few more questions roll in here. Let's start here. So Dot Morton is asking, will we see title bar customization support on Windows 10? Miguel, that sounds like it might be a question for you.
Sorry, what is Morton asking?
Will we see title bar customization support on Windows 10?
Well, this is similar to the same question that I answered before. That the customization was up window, right?
Yeah. I think it is the same duplicate question. I think it is pretty confusing though. So there's an there's an API named App Window Title Bar, and that works on Win 11, but not Win 10.
Yes, correct.
There is custom title bar support in WinUI 3, which is a XAML feature independent of the App Window Title Bar API.
Yeah, that works in Windows 10 and Windows 11.
Yeah, and I can't remember if that is customizable with resources or anything like that.
Yes, you can get the
Put you on the
style.
spot. Put you on the spot. I'm sorry. So I guess I just want to call the distinction. There's the app window title bar API, and then there's XAML custom title bar. And we're looking at ideas for making them more integrated, but at the moment the difference. So if you're looking for customization, you might be able to do it with the XAML custom title bar, and that works the same on 110 as it does on 111.
Perfect. Thank you for clarifying, Mike, and apologies to have asked again. I figured this one was specific to the Win10 question, which the other ones may have been too. I may have just already forgotten that. Yeah, so Morten, we did have some content on that a little earlier in the Q&A that I think will be interesting to you. So Arthur's asking whether we expect there to be native compilation. Mike or Scott, perhaps a question for you. I see Scott's actually engaging on that already, I think.
Yes, that is the follow-on, the successor technology to .NET Native. There's also Ready to Run, which is an ahead of time compilation, but that's not what Arthur is asking about, I don't think. He's asking about complete native compilation, and for that, it's the native AOT technology that .NET Native or that .NET is rolling out across several releases. So I don't know what the current state of that technology is. I don't know if it's fully usable yet in a Windows App SDK C# app, but I would be following. I dropped a link earlier, a URL. I'd be following the .NET team for that, for the developments there.
Awesome. All right, and I think perhaps the last question I saw squeak in here, maybe Ryan, you just answered it, was Grape was asking if there's any estimate for official UWP WebView 2 release.
Yeah, we're trying to get that out as fast as we can. We've basically got it all integrated and ready to go, but there's some underlying issues in the web platform that are holding up its release. So it's not really so much a WinUI thing as the actual fundamental engine itself. So as soon as we get those fixed, we'll get it out as soon as possible is the answer, and won't be too long.
Fantastic. All right, well, I think for real this time, we've now wrapped up all of the questions both here and on GitHub. But I will say, again, for anyone tuning in, if we didn't catch your question for any reason, please feel welcome to post it on the GitHub issue for this call. We can continue the conversation there. And again, we'll be back about this time next month. So with that, thanks to all of our team members for tuning in to help answer questions, and to our viewers for asking them. And I'll turn it over to Gabby to close out the call.
Awesome. Thanks, Savoy. Yeah, thanks for hosting Q&A and repeating what Savoy said. Thanks for our guests who came and joined us today. There's some awesome demos and lessons info to learn. So it was a great call. And so it was a bit, as you might have seen, it looked a little bit different than it has before. Let us know in the issue, the GitHub issue, your feedback around this call, around content, appearance. I know there's a bump at the beginning with the incorrect link. Next time, should be all fixed. So thank you so much for continuing to stick with us, listen in, and we look forward to seeing you on GitHub and next month. Awesome. Thanks, everyone. Bye.